Hello and welcome. My name is Eitan Suez, April 2023. This recording is an exploration, essentially my way of communicating with you, an exploration I did with Istio involving specifically Spring applications, answering the questions how to build Spring cloud native applications, what the architecture might look like with Istio in the mix. Now before I get started, I'm going to go ahead and spin up a GKE cluster that will be the basis for our the installation of this sample application. So let me give you a little bit of the context. Pardon me. The context is that for a long time now, Spring developers, the Spring framework has existed for a long time, and developers have and many enterprise developers use the Spring framework in their work, and a demo application was built by the authors of the framework years and years ago called the PetClinic sample application. I think there's a screenshot of what it looks like here. It looks very, very nice and clean. So the domain here is essentially you have veterinarians and pets and their owners, and they make visits to the vets to take care of their health and whatever other needs pets have. This application was built a long time ago and then was somewhat revived over the years as the landscape changed, as the Spring Boot came about, for example, or new versions of the Spring frameworks came about, and most recently as the cloud native applications have become sort of the predominant way of building sort of internet scale apps. So I think the diagram on the right here is a good illustration of a variant of the Spring PetClinic application that exists today for microservices that illustrates more or less the vision that the Spring framework authors have for how to build this. So you have individual services built with Spring Boot. Some of them are backed by some kind of backend database. Could be a cloud database or what have you. And you have a number of infrastructural services, Eureka Service Discovery and the Spring Config Server are some elements of the solution. You see also an ingress gateway. The Spring Cloud Gateway is yet another Spring project that serves that capability. Okay, so this picture and this architecture really predate Kubernetes. It came about around the time that Netflix moved to the cloud, so the Spring team sort of caught this early on. And so there's a sample application known as Spring PetClinic microservices. Let me show it to you. There's a different GitHub repo for each one, and there's a number of variants. So this microservices version, I think, does a really good job in the README of explaining more or less what it's about, where it was derived from. So there was just a plain monolithic version based with the front end based on AngularJS. But the idea of splitting some of these concerns into multiple microservices. And so there's a microservice for the vets, there's a microservice for the customers, which are the pets and their owners, and one for visits. And here they detail the different libraries and components that they rely on from the Spring ecosystem: the Spring Cloud Gateway, Spring Cloud Circuit Breaker, Spring Cloud Config, micrometer tracing, resilience for J, OpenTelemetry, and Eureka Service Discovery. So lots of Spring Cloud projects help with service discovery, client-side load balancing, dealing with maybe resilience issues in terms of making service-to-service calls over the network, and so on and so forth. Now, a variant of this project was created at some point called Spring PetClinic Cloud, which demonstrates or adapts the same solution for Cloud Foundry and Kubernetes, which are two different sort of deployment targets in the cloud. Cloud Foundry is the sort of former, more venerable one, platform as a service. Kubernetes, of course, is a new sort of de facto standards for cloud native applications. And little by little, what you see happening here is some elements of Spring Cloud are no longer necessary in certain environments, like in Kubernetes. The service discovery, Eureka Service Discovery is issued, is no longer needed, even though they didn't really bother to delete that module there, as far as I could tell. And this variant of Spring PetClinic, the discovery server, is no longer used. And that's sort of the theme as you move further and further away and adopt Kubernetes and Istio as your platform. Many of these Spring Cloud projects have an alternative. And so you have to sort of choose which one you want to use, which one you want to adopt. And so I went through essentially a derivative or an adaptation of Spring PetClinic from the cloud version to using Istio. And the first thing we're going to do is set it up. And I provide instructions here in the README that explain how to set things up either locally with a local Kubernetes cluster based on K3D, or with a remote running Kubernetes cluster that may be running in some cloud provider of your choice. I tend to reach out to GCP, and so I'm in the process of standing up a vanilla Kubernetes cluster in GCP using GKE. All right, so let's talk through. The first step of this recording is essentially going through deploying the thing, just so you understand the pieces and the elements, and it'll help us understand the architecture as well. As a matter of fact, now that I think about it, I do have an illustration, essentially, of what we're talking about here. Let me see if I can make that a little bit bigger. How do I zoom in? There we go. So the idea is you have ingress, gateway, a routing request to the PetClinic front end, which is one of 4 apps that are stood up in Kubernetes, and 3 backing services: the vet service, customer service, and visit service, and they each have their own separate database where they store their data. So that's the basic architecture. It looks like our cluster is ready. We can also check here in my Google Cloud Console that I have indeed a Kubernetes cluster. It's called my Istio cluster. You can make it out here. And I can likewise do a gcloud container clusters list, and I should be able to see list my cluster is there. Great. And if I just check that I can talk to my Kubernetes cluster, my kubeconfig is configured already to talk to it. So there's nothing installed here other than Kubernetes. And the first thing we're going to do is install Istio. So I'm using the current version of Istio, which is 1.17.1, and we'll take a look at this manifest here that configures some facets of Istio. The main thing I do here is turn on full distributed tracing sampling to 100%, just to make it easier to see distributed traces at some point. And the other thing I do is I turn on a feature that allows the proxying not just of HTTP workloads, but MySQL workloads as well. So if we look at the manifest, I think it's called the install manifest. What you see here, let me make this a little bigger. Essentially is my configuration. So I turn on, proxy sidecar logging to standard output. I set the trace sampling to 100%, and somewhere along the way I also set the MySQL filter to true. That's really most of the things I do in the configuration. So basically now I have Istio installed. You could see these check marks telling me that Istio has been installed on my cluster, and if I type Istio cuddle version, I should be able to to see that version 1.17.1 is installed. Great. And if I look at my namespaces, I should see the Istio system namespace, and in it I have Istio-D and my Istio ingress gateway. And we can also see the ingress gateway load balancer service and its external IP address through which I should be able to access any services that I expose from my mesh. All right, so I've installed Istio, and we're going to deploy this PetClinic application. So I'm going to deploy it to the default namespace, and step 1 obviously is labeling that namespace for sidecar injection, which is pretty standard in Istio. And then we're going to begin by installing in this picture the databases, and they're MySQL databases. There's a Helm chart for them, so that's pretty easy to do. So I'm basically adding and updating my Helm repo. The Bitnami repo has a MySQL Helm chart, and I just do a Helm install. So the only thing I configure here is the name of the database. It's going to be called Service Instance DB. It's going to have that same name for each of these 3. Remember, these are 3 separate deployments of MySQL. So there's no conflict there in terms of using the same database name. So we're going to have 3 databases, and we're going to have 3 cluster IP services, essentially, that are going to be the endpoints to access the database. So you see the visits DB and the vets DB and the customers DB. And those obviously will be available internally in the mesh to the applications that talk to those databases. So we have a service dedicated to each database, the vet service, customer service, and visit service. And those will talk to these databases and set up the schema. This application uses the standard Spring Data JPA project to configure everything and to sort of preload the database with some sample data. And here we give you the instructions for building the code when you check out this repository. I've already done that and pushed my images to an artifact registry that I've already configured in my environment. So I think it's called, push and pull image registry. This is my registry where my 4 artifacts are located. We can go and take a look at it if we're really curious. We can look at the artifact registry. And in here I should be able to see the images that contain the code that I built. So there's a PetClinic customer service, a front end, a vet service, and a visit service. These are the 4 images. I suppose I could also fire up IntelliJ IDEA. We could look at the code at some point as well. All right, so so I've got my images. Now I want to deploy them. So there are deployment manifests, and you'll find them in the manifest subfolder. I can hold on. I can bring that up here. Spring PetClinic Istio. And you will see here the manifests folder containing a variety of YAML files. So if I make this a little bit bigger, how do I do that? Control plus maybe. Oh, I don't know. All right. So what you see here is a deployment of one of the 4 services, and that involves several Kubernetes resources: a service account, a cluster IP service. The port I use is 8080 throughout, and the deployment itself. This is the customer's V1 deployment, and you could see the service account name is associated here, so customer service, and the image is the PetClinic customer service image we were just looking at in the artifact registry a moment ago. So there's also a liveness probe and readiness probe. Those are sort of inherited from the previous version of the Spring PetClinic application. And resources and requests and limits and some environment variables. So how do you access the database, right? So the credentials are in a secret that was deposited when I did a Helm install of that database. All right, so you'll see a customer service, you'll see a vet service and a visit service that follow the same sort of pattern. There's also the typical Istio sleep application, which is useful for making requests from inside the cluster, and then a configuration of the ingress gateway. So here you'll see an Istio gateway object that essentially configures the HTTP protocol on port 80, and then the virtual service objects, which essentially will route incoming requests based on the matching URI prefix to a particular backend service, the customer service, the visit service, and the vet service, and the front end service is really the one that dishes up the user interface. Okay, great. So I'm about to deploy this. What do? I didn't do anything fancy. I'm basically catting all the YAML files, do an environment substitution to reference the image registry from which I'm fetching the images, and doing a kubectl apply. So as I create these, it shouldn't be much of a surprise the type of things that get created. So we'll see the customer service is coming up, and the vets and the visit service and the front end service and so on. What else? So we'll wait for these to come up, and then we will test that the application is running. We'll check the application. I have a simple environment variable I can turn on here, which will grab the load balancer IP address in my and we can maybe go and visit that IP address. And if I don't know if I've done this prematurely or not, it looks like everything's running. So here it is, the Spring PetClinic application running on Istio. Now I haven't really altered any the application. So here you'll see all the pet owners and their pets. So we could look at, for example, I think Gene Coleman has a couple of pets, I think Max and Samantha. And each of them had a couple of visits, so you can see that there. And you can also look at the vets over here. And there's obviously other operations that can be performed, like adding a pet or adding a visit or editing the owner or what have you. So you kind of get the idea of what the application does. All right, so that's the deployment of the application. Now, a couple of things we could do just to check that everything is installed correctly. We could test the database connectivity. So we can grab the value from the secret of the MySQL password for one of these databases. I think I pick on the vets database. And I'm using the fish shell here, so it's slightly different syntax. So I set my environment variable, and then I can create a pod. This creates a MySQL client image container running inside a pod that passes in that environment variable for the MySQL root password. And as soon as I get a prompt, here we go, we can then run a MySQL command to talk to that vets database. And we could do show databases, and we should see that service instance DB. We can use that database, and then we could show tables, and we should be able to see some vets related tables. So we could do a select star from vets and see that we have some vets in our database, and that's great. And we could do the same thing in the context of some of the other databases that we have running, the customers database and the visits database. So let's talk about an analysis of the changes to the code that I've made, and for that we really have to inspect some of the code base. But let me talk you through at least high-level context, so you understand more or less where this all comes from. Right, the Spring framework has existed for a very long time. It's been sort of the foundation for sort of separation of concerns inside a single microservice application for many years. And with the transition to cloud-native applications and multiple microservices that need to communicate with one another, the Spring team sort of looked at what the industry was doing. Specifically, Netflix was one of the pioneers in that space that started solving some of the problems in distributed applications, things like service location, service registries, and how do you load balance requests between services inside your mesh before mesh existed, and so Netflix had a simple library called Ribbon, which piggybacked on Eureka to essentially be aware of the IP addresses of all of the instances of a particular service that you want to call, and then load balancing across them. There are a number of concerns that pertain to load balancing, to retries, circuit breakers, and resilience and service discovery. And many Spring Cloud projects were built using some of those Netflix OSS libraries as sort of a starting point. And it's been very, very successful. Now enter Istio. Istio takes a different approach. Many of these concerns are solved out of band, as it were. And what I mean by out of band is these applications don't have to be disturbed in order to derive these benefits, because the Envoy sidecar really takes care of many of these issues. And so you can really have a true separation of concerns in a microservice application, whereby the application can function and do its business. So we could take a look, for example, at the just a simple vet service endpoint. There's a vets controller. I need to make this bigger. And I'm not sure why this is showing up with annotations. Here we go. Let me make some of the font size a little bit bigger. Editor. Font. Here we go. It looks small to me. This is maybe a little bit better. All right, so you see a vet controller which has an endpoint that will list all the vets. I'm really not crazy about the name of this function, but again, this is not the point of this is not to refactor this code base, but it basically delegates the call to the vet repository, does a find all, it grabs all of the vets in the vets table, right? And you can sort of see from the model that the vet domain object is mapped to the table called vets there, and it returns that data. And then the client-side code, the JavaScript will sort of render the list of vets. So let me go ahead and pull up that page so you can sort of see sort of what gets rendered on the client side. And that's what these applications should be about, the business logic of sort of, essentially providing implementations for the various endpoints. Here it's a little bit anemic, but maybe, again, it's a demo application, so it's not, we don't really give it that much stock. The front end is an interesting endpoint which we can look at. There is a PetClinic controller that gets owner details, which does an interesting thing. It's kind of an aggregation or a merging of data from two backend sources. So it has a client for the customer service and the visit service, and for a given owner, it will provided as a path variable. See the owner ID. It'll go ahead and fetch information about that owner, but it'll also go ahead and fetch all of the visits for that owner's pets. And so here you see some reactive code that does some transforms and return it adds visits to owners. So a lot of the sort of merging of the data actually shows up is done here, and there's kind of a fallback here. We'll talk about this later, that if a call to the visit service times out for some reason, then we're not going to fail. We're just going to return an empty list. So we see an empty visits for pets is sort of a mapping from a throwable. So if we get an exception, we're going to swallow that exception and return an empty set of visits rather than show some kind of 500 error or something of that sort, or some kind of message. Okay, so the idea here is for the code to do what it does, and not for each of these microservices to be laden with whole layers of other libraries that need to be and dependencies that need to be sort of inherited or not inherited, but included in the project in order for the application to function properly. Things like doing retries. This happens transparently in Istio, so you don't have to configure your application for it. Even better, it solves the whole problem of polyglot, right? If you have a cloud native application, you have hundreds of services. They're not all going to be written in Spring, and so if all of these services need to participate in the mesh, so to speak, the previous solution of requiring every instance to be a Spring application so that you can import all the right dependencies, the Eureka service registry, and so on, it becomes increasingly untenable. So speaking of dependencies, we can look at any of these POM files. Let's look at the customer service, for example, and the type of dependencies I ended up with are completely devoid of Spring Cloud projects, which is great. You have the Spring Boot Starter Web. That's because there are REST controllers that need to be implemented. The Spring Data JPA is the foundation for the database access. You see here the JDBC driver, which is a runtime dependency. This is a Java app that's using Lombok, which is a project that helps deal with some boilerplate. That's more of a historical artifact, I think, at this juncture. And some annotations for validation of data, which again is kind of a detail. And then the Spring Boot actuator, which helps expose information, metadata about every running service. That's always kind of a standard thing to do in Spring Boot. And what gets interesting here is the fact that we can expose metrics about our application to Prometheus, which is something Istio supports sort of out of the box. And so the application can expose its own metrics. So we ask Micrometer to provide a Prometheus endpoint, a scrape endpoint. And then as we'll talk about in just a minute, Micrometer tracing provides support for propagating trace headers, which is the main reason this dependency is there. And that's it. Right, there are no Spring Cloud dependencies in here. No Eureka Service Registry, no ribbon, no resilience for J. All of that stuff is sort of provided by Istio, and we can look at some of these manifests that, for example, that replace what resilience for J used to do. So one of the examples in the original application used to use resilience for J to specify a client-side timeout of 4 seconds when calling the visits service, and that's easily implemented here. with an Istio construct, right? A virtual service with a timeout. That's just one example. The other big sort of elephant in the room here is the fact that Spring Cloud Gateway was utilized as sort of the ingress gateway. That's the bread and butter of Istio. And so with Istio, you can define your routes very much. This was a direct one-to-one port from the original Spring Cloud Gateway configuration. I'll show you what it looked like before, to expose the necessary endpoints for this application to function. And so I basically did short work of all of these separate concerns: the routing concerns, the ingress concerns, the implementing specific timeouts for calls to specific services using Istio CRDs. And the applications no longer need to have any of these Spring Cloud dependencies in them, and that's the crux of it. All right, so we let's do a few specific tasks that expose specific features. I suppose one of the things that we could start with is exploring some service endpoints. So I'm going to go ahead and copy and paste some of these. So and there's two ways of running some of these calls to some endpoints. So for example, here I capture the name of the sleep pod. And so from the sleep pod, which is running here, you could see sleep right there. I can make calls using curl to other services from inside the mesh. And so this example command right here does a curl to the vet service and gets the list of vets, and you see the JSON that gets returned. Now the UI of the application transforms that information and renders nice HTML from it. And that's what the Angular part of this application does. So you see the list of vets. I could have equally made a call through my load balancer IP address directly to the vet service, because that endpoint is exposed through my ingress gateway. And you get the same information. So you get the list of vets this way. You can get the list of pet owners, or we can look at one specific pet that belongs to owner with ID 1. So here we can essentially see that the owner, George Franklin, has a pet named Leo, which is a cat. Likewise, we can look at some of the other, here I can pick on the visits service and look at the visits that pet ID 8 has had. So they've had 2 visits, a rabies shot and an operation that I rather not think about. All right, so these are the endpoints. The application is up and running. And the first thing we could do is test resilience. So one idea, one bit of code in this application that used to exist was a dependency on resilience for J to apply some kind of timeout so that if some service took longer than necessary, to fail fast and to essentially substitute an empty list of visits if the visits service wasn't responsive. I've taken that code out. There's no longer a dependency on resilience for J, and instead the timeout is specified in Istio. I showed you that a minute ago in a timeouts.yaml resource here, timeout of 4 seconds. This is, again, we're just playing. This is not a realistic sort of production type timeout that you'd set. But what we can do is exercise this. What if we could instrument the visits application to take more than 4 seconds to respond? How would the front end service that makes a call to the visits service react? Right? Would it be able to sort of fall back and sort of capture that, sort of not wait forever, right? Which could actually cause the calling service, the downstream service, to get under increasing strain in high load situations. So we can call this endpoint, the visits endpoint. Notice that it's succeeding and it's coming back in a very short amount of time. And we can call the front end endpoint, which is in turn calls the visits service. And you could actually see that these visits here are actually embedded here under visits under that particular owner. So you have a situation where the front end is calling the visits service. So if I were to try to, we're actually making a call through the gateway to the PetClinic front end, which is calling the visits service as well as the customer service and aggregating the results. And we were looking at that code a moment ago. Let's go back there. So the PetClinic controller has this method called getOwnerDetails, which is calling the customer service and the visits service and then returning a response. And here we look for a timeout. All right, so I can edit the visits deployment And there's an environment variable that sort of I use to instrument this scenario. I can put in a 5,000 millisecond delay. And when I modify this deployment, excuse me, a new pod is being rolled out with the updated environment variable. And we can make the same calls again, right? So let's go back to my little cheat sheet here. We can call the visit service, and we should see that when I make this call, this is going to take at least 4 seconds until the timeout kicks in. Notice it doesn't wait the full 5 seconds for a response, and it returns a 504, which is a gateway timeout. Okay. Now, when we make the call to the front-end service, which calls the visit service in turn, what you'll see is, again, this takes 4 seconds. But at the end of 4 seconds, when the timeout is hit, you see the fallback of just setting the list of visits to an empty result set. So you achieve essentially the same sort of behavior that we've had before with Resilience for J, but using Istio constructs instead. All right, so let's sort of reset my service to just not have any delay. And let's look at some other facets of features that Istio sort of brings to the table. And the one that I think is probably most talked about because of its immediate benefits and relatively low cost to adopt with Istio, this is completely transparent almost, is the fact that all workloads have an identity based on the SPIFFE standard. SPIFFE stands for, what is it? Simple Production Identity for Everyone, something of that sort. It's a framework for using X509 certificates to essentially configure communication inside the mesh to use mutual TLS, and where the identities of each service can actually be used as a mechanism for workload identification and authentication. And based on that, we can define an authorization policy. And so I'd like to just invite you to look at a very simple use case. This authorization policy, actually there's several, there's 3 of them. They do the same sort of thing. It basically says, for the vets database, allow calls from workloads. The source principal is the identity of the workload, called the vet service. So if the vet service is calling the vets database, let it in on port 3306. And that's a simple way of ensuring that no other service is trying to go behind the back of the microservice that's really in charge of vets, right? That's used to be a serious problem in the enterprise, whereby the sort of the point of integration between different development teams used to be the database proper, which was a serious problem for abstraction and for evolution of code bases. You cannot integrate with the database. And so I can actually enforce that no one else talks to the database other than the vet service, and I can apply this authorization policy. And there's 2 ways to determine whether this authorization policy functions. One is, if I were to do what we did a moment ago with the MySQL root password, I think I still have that environment variable in there. That's great. And so we can try to connect to that database again with the credentials. And notice that we won't be allowed to talk to it. So how do we do that? Let's see here. Okay, that's the command I was looking for. So we're going to run this vetsdb MySQL client. That's going to give us a pod. And then inside that pod, that prompt, we're going to try to talk to our MySQL database. And notice we get an error message, SSL connection error. We're no longer allowed to talk to it. And that's because in front of that database is an Envoy proxy that is ingested that authorization policy. It knows the identity of the caller. I am not the vet's service, and so it didn't let me in. On the other hand, if I was the vet's service, let's look at an endpoint call. If I were to go to if I were to get the list of vets, which will give me which will make a call to the database, give me the list of vets, of course, that's going to succeed. Okay, and that's because my call from the sleep container went through the vet service, which is authorized to talk to the vet's database. Right. All right, so you can get an idea for how workload identity is really useful and can help. Let me go back to my little Where were we? We were talking about workload identity here, right here. And we just ran through this exercise of tightening down the rules in my mesh. And those rules can actually be set by another separate team if we wanted to. We didn't have, you could have a security team that's in charge of this. And so you unburden your developers from the task of dealing with some of these security policies, which they're usually a little less interested in than working on sort of business features. And so you can make authorization policies based on workload identity, which is something that you cannot do in many other environments, at least not with this level of ease. All right, another thing we can look at is observability. We get a lot for free with Istio in terms of observability, right? The Envoy sidecars that are deployed alongside each workload, right? If we look at these pods, they each have 2 containers. One of them is Envoy. Let me go ahead and delete this MySQL client pod. I'm not sure why it doesn't terminate properly. No big deal. And we can deploy the Prometheus and Jaeger add-ons. I'm maybe just do these 2. So I've got my Istio distribution here, and I've got here we go. So we'll do a kapply-f Prometheus, kapply-f Jaeger. We can also look at Kiali. Maybe we'll do that later. Okay, so the envoys expose a Prometheus scrape endpoint. And that basically means that metrics can get collected for all the services in my mesh. And that includes the custom application-specific metrics in addition to the metrics that Envoy collects. So there's kind of a metrics aggregation that goes on here. Maybe I'll start with that. Maybe we'll talk about the metrics exposure kind of idea here, right? So if we look, for example, at the customer's pod. There we go. That's its name. And we can make a call to the expose. This is the Prometheus endpoint exposed by the application. Okay, the application exposes the Prometheus scrape endpoint. This is from Spring boot and Micrometer. Micrometer gives us all of these, which is terrific. A lot of JVM specific metrics are available here. Spring data repository metrics, all kinds of interesting stuff. And that's very, very useful. And those are the metrics exposed by the app. Now there's another metric, another set of metrics, another Prometheus scrape endpoint on port 15090, is that right? There's 3 in total that I want to look at. Yeah, okay. We're going to look at that, and that's Envoy's metrics. Again, another separate endpoint containing Envoy server initialization time, all kinds of other. The typical one that I pick on here is Istio request total. You can see here a variety of Prometheus metrics that expose. Actually, this is the same, multiple dimensions of the same metric. So all of these metrics are exposed through 2 separate scrape endpoints, and there's another endpoint that sort of aggregates these 2. So the one on port 15020, which is the one that Prometheus ends up scraping, contains a combination of both the application metrics and the Envoy collected metrics. So you can see them all here, which is great. And you should see some JVM stuff in here as well. I don't know if we've already kind of gone through it. So you see a lot of information here is collected. I'm not going to go all the way to the end. So you have these scrape endpoints that Prometheus is actually collecting here. I think the default period is every 15 seconds or so. And how does Envoy know where to collect the application-specific endpoints? And you could see that in the deployment manifests. So one of the areas of the deployment manifest I'd like to draw your attention to is the metadata section of the deployment manifest, which specifies annotation, at least with the pod template spec. And these annotations basically speak to Prometheus, and they say, by the way, yes, there is a scrape endpoint for my application on port 8080 at actuator Prometheus. That's the endpoint to go. And so actually Envoy is the one that ends up getting this information and grabbing those metrics and exposing them alongside the metrics it collects. So we'll see those metrics in just a minute. Maybe we can fire up the Prometheus dashboard and look at them. We can do that. Why not? See Istio cuddle. I'm deviating a little bit from my sort of my cheat sheet there. So if I do an Istio cuddle dashboard Prometheus, and one of the simple things I could do here is look for that same Istio requests total sort of metric, and we could see a graph of that information maybe over the last 5 minutes. And you could see obviously there's not much traffic being sent to this application, so that would make more sense to do while we are maybe running some traffic. Maybe we'll do that in just a minute. All right, so let's turn our attention next to distributed traces. So a couple of things to say about distributed traces. One is, how exactly do I... There is a requirement in Istio. Istio cannot do this for us, that applications in the mesh propagate these B3 headers in HTTP requests. And so that's in the code. I can show you exactly where that is. There's, I think it's an application.yaml file. We can look at the at any of these. Yeah, so you see the tracing, I think it's under management tracing baggage, is where you could specify a list of headers that you want your application to propagate. So that's the only thing I had to do in my applications that are not directly related to the business logic that each application has to perform. And so once these trace headers are propagated with micrometer tracing, what we can do is send in a request. That's what I do here. So let's go ahead and fire up the... we can look at the pods in Istio system and C-Ns. All right? And we could see that Jaeger and Prometheus are deployed. I guess that's step one. Step two is Istio cuddle dashboard Jaeger. And Jaeger is one of several different distributed tracing solutions you can use. And you could see that the PetClinic front end, for example, is already showing here on the list because I've made some requests to my backing application already. Let's go ahead and make another one. Let's call, maybe instead of calling sleep, I'm going to go through the load balancer IP address. I think I have, there it is. I can do a curl through the load balancer IP address to the API gateway owners /6. That will return information about this particular owner. And when I make that call, because I have 100% trace sampling turned on, I should be able to then come back to my to here and look for traces, and I could find here a trace with 6 spans, and you could see these 6 spans. I'm making a call through the ingress gateway that's calling the PetClinic front end, which is then calling the customers and visit services. I'm not sure why the visit service took 450 milliseconds. It'll be interesting to see if I call this multiple times, if I have some. This might just be some of the variants that we see when we don't. Yeah, that's front end visits. Yeah, that's 18 milliseconds. That's much better. That might have been some kind of warm up time. Okay, so you see distributed traces. It all works just out of the box. I didn't have to set up anything. And you could also bring up the Grafana. We could deploy the Grafana add-on and show you the Istio Grafana dashboard and send a request. So there's full coverage of observability. We could see the metrics, the logs, the distributed traces, which is terrific. But the point that I think needs to be made here is not so much that those are available, but that you didn't have, your application development teams didn't have to code into their independent applications all kinds of instrumentation to sort of enable this. Obviously they can further customize these whatever dashboards are available and so on, but the whole point here is a clear separation of concerns where your development teams are not burdened with extra responsibilities because there are so many cross-cutting concerns in the cloud-native application, whether it's security, observability, and so on. And you also get uniformity. And what I mean by that is that your dashboards are uniform across all your services. So maybe the last thing we could do, let's go ahead and deploy I'm going to deploy Kiali. And maybe we can do an Istio cuddle dashboard Kiali, and maybe before, I think I have a siege command. Let's see, how does that work? Yeah. All right, so I'm basically calling that owner's endpoint, looking for, sort of sending some load to my target application. And there's my Kiali dashboard, and I can look at a graph, and it looks like the default namespace is already selected. That's great. Maybe I'll hide this so that I can. So what you're seeing here is a live. Maybe I can turn on traffic animation, makes it a little more interesting to see. But a live calls that are happening through the Ingress gateway to the PetClinic front end, which are calling the customer services, and all of this, all the way down to the database, is actually visible through observability, right? We can drill down and go into each service and look at their metrics and what have you, and you can see here, everything is 200 HTTP responses, and you can also look at the volume of requests and other information, and we can also come over here to the service and get some metrics from it as well, I believe. It's been a while since I've looked at, yeah, here we go. We have inbound metrics. You can see different metrics corresponding to the request volume or request duration in milliseconds, or the request sizes and the health of each of these services. So that's Kiali in a nutshell, but and there are other tools besides that do the same sort of thing. Terrific visibility into what's happening inside your application. And we can also maybe at this point also bring up the Prometheus dashboard again, because now we should have some more metrics. And so if we look at Istio request total and look at the graph again, yeah, well that's increasing. Of course, it should get to and then you can look at the rate. It's monthly and increasing. This is the counter. The rate over the last 5 minutes, I think, is how that's done. Okay, that's not a very interesting picture. But this obviously, with PromQL queries, you can sort of narrow this down. You can look at the request to a particular service, or the ones that might have produced a response time of, a response code of 200 or 404 or 500. And you can look at the distribution of HTTP response codes or what have you. Okay, all right. And the reason this dashboard is no longer showing any information is because I just turned it off. Okay, so that's let's go ahead and try to summarize what I've done here. You can obviously check out the code base and look at the code yourself, and the thing that you'll discover if you compare it apples to apples with its predecessor for the version of Spring PetClinic from which I derived this particular Istio implementation is the complete absence or the replacement of all these Spring Cloud libraries with Istio, and the fact that a lot of these. So one thing that I want to point out, which is very very important, is the fact that when you remove the coupling, right, between the application and the way that you configure some of these things, like some of these resilience concerns or what have you, is you don't have to stop and restart and reconfigure your application every time you want to modify something that's really orthogonal to it. You can just modify this CRD, right? So your application keeps on running and it does its business, and it's the sidecar that is configured and programmed with these extra concerns on our behalf. I mean, that's very, very powerful. All right, I will stop here. I hope that you find this project useful and compelling, and it give you some kind of a blueprint for how you can really go back to basics with Istio, with Spring Boot. So you have Spring Boot applications that do their jobs, and it's ensuring that your platform is resilient. Doing blue-green deployments, canary deployments can all be done without disturbing the applications or even restarting them, right? So you deploy another application, you configure a virtual service to slowly siphon traffic away from the version 1 to version 2, for example. And that's all done with Istio. You have complete observability, uniformity in the way these metrics are collected. And it brings a lot of sanity into, especially when you have a very large number of services, into the practice of running cloud-native applications. So it's the combo of Spring providing sanity inside each microservice, and Istio providing sanity across the mesh between services in what we call a cloud-native application. All right, thank you for your time.